But and if you wanted me to tell you which one to guess, yeah, I don't know. Maybe C. Maybe C. C is always a good guess.
Okay.
Okay. Now we're looking at the next one here. All right. So there's only one that is the quadratic formula again. Quadratic formula is I mean, there's not, I either just tell you or you have the right answer. So there you go. Number 2.
Hmm.
We will be using that later on. So we're gonna just say, okay, there it is.
Mhm.
All right. So number 3. So that was a pure definition. All right. So perfect square trinomial. A perfect square trinomial has this form. It's ax squared. Sorry, that's not right. It is something in the form of a squared minus 2ab plus b squared. And what this means is, I know this looks really bad, is that it means that you can take the square root of the first term and the square root of the last term for sure. That's your starting point. But there's
Mhm.
also the possibility that it's plus,
Okay.
which is a plus b squared like that.
Mhm.
Now, again, like what we're looking for is something where you take the square root of the first, the square root of the last, square root of the first, square root of the last. These all appear to have that. So these are all kind of in good shape. But the other thing to notice is the signs. They're either plus plus or minus plus. So I want you to look at these 4 options and see if they all satisfy one of the 2 criteria, either minus plus or plus plus. And the order does matter. They have to be in exactly that order.
Okay. So what would be similar to one of those two? A squared minus 2ab. Okay. D minus and
No, no,
plus.
there's 3 of them have exactly the same, like option 1, option 2 signage, where there's a minus and then a plus, plus and then a plus. 3 of the 4 have that. Which 3 have the same operators, minus and then a plus, or a plus and then a plus?
A, B, and D.
D. So that means which one that is not is this one right here.
Okay.
Okay.
All right.
We will move on to number 4 here shortly. Let me snip this in. All right. Okay, so they say, factor completely. It's like clean up your room totally. Well, yeah, you can do that. There's a bunch of different types of factorings that we're going to do today. The first one is GCF, greatest common factor.
Hmm.
What is the GCF? What goes into both 3 and 3?
What goes,
The biggest number that goes into 3 and 3.
I would say 3.
3. Very good. That's part of it. Now you've got x cubed and x to the power of 1. What is the smaller exponent between them?
X to the power 1. The smallest.
So you divide each of these by 3x to the power of 1. Okay, can you try, I know it's been a while since we've worked together, but hopefully it's still there. We just get the neural pathways rebuilt again here. What is 3x cubed divided by 3x to the power of 1?
Would be x squared.
X squared. Okay,
Yeah.
good. Minus.
Minus x. Well, no. So
It's the
minus
same
7.
on the top and the bottom. Same top, same bottom.
So just be 3x. Would be the same. Well,
What is
x
4 divided by 4?
1.
Okay, why is it 1? It is 1, but why? What makes it 1?
I guess it's better than 0.
Division is sharing, right? You have 4 things to share and 4 people. 4 slices of pizza, 4 people. How much
Mhm.
pizza does everyone get?
One slice.
One slice. So when you have the same on the top, same on the bottom, it's one. Top and bottom are exactly the same.
Okay. So it'd be one.
Yes.
Put that down.
Okay, now we're not done, but that's the starting point.
Mhm.
Same top, same bottom is one. Okay.
Okay.
Okay, now this part inside parentheses here is called difference of squares. Do you remember us doing that?
Um,
It's okay to
don't
say no. I'm
believe
just trying
so.
to. We for sure have, but it's okay if you don't remember. Like this is part of
Mhm.
factoring. So it's a squared minus b squared is the setup. Like something squared minus something squared. You might say, well, one isn't squared, and I'd say you're right, it's not. Now I put a two there, and now it is because one
Oh,
squared is really one. It's exactly the same as one. So we have x squared minus one squared, a squared minus b squared. So that's a minus b, a plus b. Okay. So what you're looking at here is you can rewrite x squared minus one as something in parentheses here. And that something is based on, well, what is a? A is the thing that you're squaring. You're squaring x. X is being squared. So in your problem, a is really x. B is the thing that you're squaring. One is really b. So you're just, instead of writing a and b, you're substituting in x and one. Okay, can you attempt to tell me what goes in these parentheses here?
okay. X squared minus one squared. So I would say one X. And then X. Hmm. I don't know what would be subtracting, but adding would probably be 1x to the fourth power or just 1x squared.
Okay, notice again, like a is the thing that's being squared. What are you squaring here? What is underneath the square?
X squared.
No, what what is underneath, below the square is the
Below.
x.
Hmm.
Do you see there's a two above the a? That's
Hmm.
represent the thing below the two up here. A is
Hmm.
really x.
Okay.
Same thing for b. B is the thing below the two. What's below the two?
One.
So your b is
One.
one. X minus one. What goes in the next one on the right?
X plus one.
Yes. Okay. So now your final answer here, we gotta kind of gotta put it all together, as they say. X minus one, x plus one.
Mhm. One plus one. Okay. Yeah.
Is that
Are we
okay?
there? Hmm.
Yep. Is that okay?
Hmm.
All right. We were ready to proceed to number 5. So I'm gonna rewrite number 5 in a way that's more doable for you. So notice
Okay.
I'm just erasing for now. We're gonna put it back, erasing the y and the y squared. I'm just saying ignore those completely. Okay. Ignore those completely.
Okay.
All right. Now you're trying to find two numbers that multiply to minus 16. Okay. But they have to add to minus 6.
Uh,
Multiply to minus 16, but add to minus 6.
okay. Mhm.
What would those numbers be? And I'm going to step away for 30 seconds here, but I will be right back.
Okay.
Go ahead and think about those, please.
Okay. Bring that down. 16. Well, No. Mm. Donate. No,
Right. How are you doing on that?
I'm doing fine. Three. Mm, so no, we can't do 3. Cool. Okay. I can't do 3. Can't do 3. 4. 4 times 4. But that doesn't make 6.
Let me help you out here. So the list is like 1 and -16,
Yeah.
-1 and 16, right? But neither of those add up to positive or -6 in this case. 1 minus 16 is -15, -1 and 16 is +15. You have to
Mm.
make an organized list. So 2,
Mhm.
2 and -8, -2 and 8, -4 and 4. Do any of these add up to -6?
Oh, uh, no, it would be 2 and -8.
Yeah.
There we go.
So you write x plus 2, x minus 8. And you might think, okay, well, I'm done. But remember, we erased the y and the y squared. So we've got to get those back in there. Okay. I'm going to explain how to do that in a moment, but is it clear how to factor something like this?
Mhm.
Okay. Take your word for it here. So to get to y squared, it's a y times a y. And that's where the y's come back in. You erase them and then you put them back in.
Okay.
So your final answer has a y's there on the end. It's a small thing, it's a subtle thing, but it's not a big deal. It's
Okay. 2
you know, in
y.
fairness to you, this question is probably a little early in the exam, practice here to like grow up. It's more work than you want to see at this point. But nevertheless, hey, you know what? We got it.
Yep.
All right. So let's look at number 6. All right, so number 6, different form. They remember on the tests, quizzes, exams, they always give you like a little, like one of each. You don't get a bunch of practice, which makes it tough here. There's no GCF this time. There's no number, no variable that goes into all of them.
Mm-hmm.
Okay. There is though a path forward here, which is 5 times 3. 5 times 3 is 15. Okay. And now
Mm-hmm.
your goal is to find two numbers that multiply to 15, but add to 16.
Well,
Okay. So what I recommend doing is just like I did here, create a list. This times this, this times this, this times this, 2 times 8, 2 times minus 2 times 8, minus 4 times 4. Create your list of numbers that multiplies to 15, and one of them will add to 16.
okay. I have those numbers.
Okay,
1,
what do you
1 and 15.
okay? Is that your answer?
I wouldn't say we're done.
Well, does that add to 16?
Mm-hmm.
It does.
Okay.
Okay, so now it's 5a squared, and what we're doing is we're breaking apart the 16a into plus 15a plus 1a. Do you agree that 15a plus 1a gets you back to 16a?
Mm-hmm.
Okay, great. Now we're going to look at the first two terms here. First two terms. What is the GCF of the first two terms?
To do the other thing. Let's see. Greatest common factor. For 15, I would say 3. For 5, 5. So I'm gonna have to do the thing we did with the last question.
Nope. What is a
No.
GCF?
The greatest common factor for,
Have we done,
okay.
have we done a problem today with the greatest common factor?
Yes.
Yes, and remember, like, I'm showing you, I'm like showing you, okay, I showed this to you. We worked this out together. I'm not asking you to come up with something new, innovative. I'm just asking you to apply what we've already done today, and you can do that.
I'm
So
trying
what is the
to,
GCF between 5a squared and 15a?
would I have to make it, let's say, in 20a squared and then find that, or just separate? Do
Well,
them
let's look at this
separate.
problem here. What is the GCF of number 4?
Greatest common factor. We had 3x1
3x1. So why 3? Where could the 3 have possibly come from?
from the 3x1.
Cubed and the 3x. It's the same in both. In fact, I said multiple times, it's the biggest number that goes into both. Now, why x1? Why not x cubed?
We divided.
Well, we do ultimately divide by the GCF, but you, and this comes from a past lesson, you take the smaller of the two exponents.
Mhm.
So you find the biggest number that goes into both numbers, and then the smaller exponent.
Okay. And the biggest.
Is that clear?
Mhm.
It's
Find
okay to say
biggest.
no, Josh. It's okay to say, like, you know what, I just don't understand it. That's fine. Then we take a little bit of a side trip and we do a few problems like that. That way it becomes clear. That's why I'm asking, because like at this point, you've got to do exactly what we just did on your own. That's where I'm trying to get you to, you know, you're riding that bicycle for the first time and you head down the road and you got to be able to tell me the GCF of between 5a squared and 15a. Like what goes into the 5 and 15, a squared and the a.
Okay. Let's see. Okay. I would say for 15, and for 5 would be 5 for 5.
Five definitely goes into 5. Does 5 go into 15?
Oh, I would say 3 would go into 15.
That is true. Does 3 go into 5?
No.
So does 5 definitely goes into 5. Does 5 go into 15?
Yes.
You seem uncertain. Do you have a calculator handy?
Hmm.
Okay, we'll just divide. Just 15 divided by 5. Does it work?
Yes.
It
3.
does. There you go. 5 works. Now, between a squared and a, what's the smaller exponent?
A.
A to the power of 1. So now you have to divide both of these by a, 5a. All right, so please try to do that for me.
A. A1 plus 10. That is the 10. Okay. 10A. Yeah. Okay. Wait, it's dividing. Okay, we're dividing. So that would be 3A. Okay.
Tell me what goes in parentheses.
A1
Okay, good. Plus,
plus 3A.
why is there an a in the second one?
Oh, yeah. They're both the same. Okay, so it'd just be 3.
Yes, very good. A plus 3. Now, in this type of factoring, which is called grouping, you immediately rewrite what's inside parentheses over here to the right. You just immediately do that.
Mhm.
Okay. And then you figure out, well, what goes here? What goes here? So the answer is like whatever goes in here, when you multiply in, you get back to the previous line. Notice a plus 3 is the same as 1a plus 3. You could think of it as a 1 there. So it's plus 1 like that.
Uh-huh.
So your result is, and now this is you have to factor out again, an a plus 3 from both. Both of these terms have an a plus 3 in them. So you factor them both out, and then what's left over is the 5a plus the 1.
Hmm.
What do you think?
Okay. Factor both. Looking at what I wrote down. Huh. So it looks like we just made it a bit simpler. We just put a plus 3, then 5a plus 1. Yeah, life will be always going to grow up. I would say that would be it, but I feel like
That is
that's
no,
not.
that is it. I'm asking if this is like there's any questions. The next one is it's not like it, but it might have elements that are like it. So I want to know if there's
So
anything here to talk about before we move on to the next question.
would you put for the a plus 3 squared because you're
No,
putting both of those?
there's no squared. It's the same in both. Since it's the same in both, you like pull it out. They both have it, so you're taking it out of both, and it's just it remains singular there.
Mhm. Okay. Okay. But okay. All right. I'm gonna grab another flashcard. Okay. +4. Okay.
Keep going here. All right. So you always start with GCF factoring. Like you always hope that something can be reduced by either a number or a letter. Look at 4, 10, and 4. Is there a number that goes into all three of those besides 1?
2. Say 2, 5, and 2.
It's got to go into all three of them. Is there a number that goes into all three? So like start with 2. Just say, okay, I'm going to try 2. Maybe it works. Just 2 go into 4.
Yes.
2 go into 10.
Yes.
Yes. Okay. So let's just try it. Like we don't have to like make a big deal out of it. Just divide each of these by 2. What is left over here?
2m squared
Good.
plus 5m
Yep.
plus 2.
Good. Now, if there were another number that was a GCF, we would see it. Like there'd be a number that goes into 2, 5, and 2, but there's not. Okay. That's
Mhm.
totally not. Now, the part that I'm about to put in red here, this is just like the previous problem. So we're going to work on that now. Actually, let me do it in blue. Red's kind of a negative. We associate red with negative. So I'll do it in blue here. So we're just going to kind of reset. We're going to say, okay, here's the problem. It's 2m squared plus 5m plus 2. And this is just like the previous problem. So let's go back and look at the previous problem and see what we did at this point right here. Okay. So why did I draw this line here? What was the result of doing that with curve?
You wanted those two numbers to multiply.
So you multiply together. So the reason we multiply them together is because we're going to split apart this middle term. So we're going to do that here. What is 2 times 2?
4.
4. Okay. Now we're looking for two numbers that multiply to 4, but add to positive 5.
Okay. I'll write this down. So, okay, so 4 makes 5. Okay. 1 and 3. It has to be times. Yeah, 1 and 4. 1 and 4.
1 and 4. Very good. So here's how we're going to do it. We're going to split apart 5m into 4m plus 1m, and we're going to bring the other stuff down. 2m squared plus 2.
Let's do, okay.
Now, do you remember what we did in the previous problem at this point?
We have my flashcard. It looks like we. Oh, I don't have everything on it. But I'm looking here. We factored, right?
GCF, yes, we found the GCF of the
Yeah.
first two terms.
Okay, I'll just say I don't know.
Say that again.
I don't know.
Okay, let's look up here. We spent a great deal of time talking about the GCF. There's a GCF between 5a squared and 15a. It ended up being 5a.
Mhm.
Okay, so 5a. You have to find the GCF of 2m squared and 4m.
Okay. 2 and 4. No, 2 and 2. 1. 2 would be 1. And 4 would be 2. I guess I'll just say 2 and 2.
It's just one number. What's a number that goes into 2 and 4?
2.
2. Very good. And then what about the m squared and the m?
M squared. We would pick the M.
Okay, smaller
Smaller one.
exponents. Now you're going to divide both of these by 2m and tell me what goes in parentheses.
Divide, that would be M plus 2M. Okay. M plus 2M.
Like this?
Mhm.
Okay. So if you look back, we are at a plus 3 because if they can't combine before, they can't combine after. But the way you've written this, it suggests that we can now add these together. 1m plus 2m is 3m. Please check your division. There's a small change that needs to be made to this.
4 and 2. For dividing.
Yes.
So
It sounds like you're making note cards, which is great. Like that is the way to go. Really the way to go. So let me scroll up and show you this because we already did this today. Right here, we did it. Why did I write this? What was the significance of showing you this?
it was to show me division and how it would be 1.
Yes, and the reason it's 1 is because it's the same on the top and the bottom. Is this the same on the top and the bottom?
Mm-hmm.
So if it's like x over x, that's also 1. Or a over a or whatever you've got here. Take a look at what you have right here. 4m over 2m. 4m over 2m.
Okay.
Is there anything that's the same there?
Um I guess 4 could be 2. And
The
then it would
M's
be
are the same. The M's
M's
are
are
the
the
same.
same.
So there's no M in your answer.
Okay. So I got it. Let me cross it
Your
out.
your your verbal body language suggests like that's me like speaking I don't know, Chinese, we'll say. Like it's like there's a disconnect. And it's okay. It's just but like when you have the same thing on the top and the bottom, it goes away. So it's just 4/2. 4/2 is 2. We had the same thing in the previous problem. Somehow we got to make that clear, but we'll figure that out here. Go ahead and get caught up here with your notes, please.
Okay.
Got it?
Mhm.
All right, so you immediately write M plus 2 over here, and then you say, well, what goes in the middle? What goes in here such that when you multiply M and 2, you get back to M and 2. And the only way you get back to yourself is to multiply by 1.
Okay. Okay. +1 and +2. Okay.
So now, and this was a little bit of the odd part. So I'm going to use the highlighter again. They both have an M plus 2 in it. So you factor out an M plus 2. Like they both have it. It's kind of like a GCF. I mean, it is a GCF, but it's not typically thought of a GCF. And then you bring the other stuff down with it.
+1. Parentheses. 1. Okay. Yeah, so, okay.
Right. And that is the final answer there on that.
Okay. I think I need to pay more attention to the little details.
Yes.
That's what I need to do.
All right. Let me know when you're ready to go on to number 8. We got a couple of true falses here.
I'm ready.
So if it's true, we write true. If it's not true, we have to make a change. So this one, it says, according to the fundamental theorem of arithmetic, every composite number. So for example, 6 is a composite number, okay? And it can be written as 2 times 3, okay? But 7 is prime. It can just be written as itself, okay?
Mhm.
So every composite number, what math operation is sum? Is that
Oh, okay. Now they're getting into terms.
which one of those 4 is it?
I'm gonna say the addition.
Yes. And this little dot between the 2 and the 3 is not addition, is it?
No, it's
It's a
multiplication.
product. So we say false, and the word they want there is product.
Okay.
Great. Number 9. All right, so it says the 0 factor property allows for each factor of a factored quadratic equation to be set equal to 0. So the idea is, let's just say you have x minus 2 times x plus 3 equal to 0. You can solve this by setting each of those factors equal to 0. That's what the 0 factor property allows for. So this one is true,
Mhm.
because that's exactly what we would do when we go to solve something.
Interesting. Okay. 0 factor. X minus 2 equals 0. X plus 2. Yeah. Oh, okay.
All right, so let's look at the next one here. Could you read that one out loud for us, please?
The variable. Oh, you have it?
Go ahead and read it. I'll snip it in here in a moment.
Okay. the variable in the linear term, the linear, I believe,
Linear, good.
term of quadratic trinomial is always raised to the first power.
Okay, so we're gonna write this out here. Here's an example: 7x squared plus 13x minus 5. So the linear term, use the pen here. The linear term is this one.
Hmm.
Do you see a variable in that red block?
Of the x would be one,
Yes.
the variable. Yeah.
What's the power? What's the exponent of this?
So 1.
1. And that's what it says there. So this is true.
Not too tough. But still
Okay,
tough.
move on to number 11 here. All right, so this is completely wrong. I think it's a mistake to show you stuff that's wrong when you're learning. It's better to have the right stuff there. So the Pythagorean theorem, it says that a squared plus b squared equals c squared. But more importantly, it's a leg and a leg. The legs, just like you and I have legs, they come out from our center. The vertex here is, think of the center. The legs come out from the center. So it's really, think of it as leg squared plus leg squared equals c is the hypotenuse squared. But
Hmm.
these letters for A and B on the legs, those are standard. You're going to see that all over the place in this course and your next one. Same with C on the hypotenuse.
Okay. It's an interesting word. Hypotenuse. Okay. Next. Hypotenuse.
All right, so we'll move on to number 12. All right, so 12 is the square root of 12, which is one problem. 15 square root of 3 is another. Minus 6 square root of 3 is another. Okay, so it's really like 3 problems in one. Okay, we're gonna work on like one part, then another, and then another. Okay.
Okay.
Now, if you recall here, we reduce the square root, reduce the root by breaking it up into its prime factors. What is the smallest? This question for you, Josh. Smallest prime number is
Smallest prime number, that would be 1.
1. Unfortunately, is composite.
Oh.
It is the only even prime number. The smallest prime number is actually even. What is the
0.
smallest? It is not 0. It
Well,
is
then it
2.
would be 2.
2. Yes. Yes. And this is general knowledge. This is stuff that we have covered in the past because we have done this before. It sounds like you're making note cards. I hope you will consider putting that on a note card, that the smallest prime number, or the first few prime numbers, are like 2, 3, 5, 7, 11, 13. And it does go on forever, but we don't need forever. We just need a few.
Hmm.
12 is 2 times what number? 2 times what number gets you back to 12?
6.
6. Very good. And then let's do the same thing with 6. Can you divide 6 by 2?
Yes.
Okay. And what does that become?
2 and 3.
2 and 3. And if you recall, you circle pairs. So this square root of 12 becomes 2 on the outside, square root of whatever's left on the inside, which is 3.
Okay. Remember a
And
little.
now
Yeah.
the next ones we just bring down: 15 square root of 3 minus 6 square root of 3.
6 square root of 3. Okay.
Now, do you see that these all have a square root of 3 in them?
Yes.
Okay, so your answer is square root of 3 here, but we have to figure out what goes next to it. 2 plus 15 minus 6.
15 minus 6. Okay.
What does that become?
17. That would be 11.
It is 11. There is your final answer.
Okay.
Okay, now, I'm gonna go ahead and stop here, but I'm gonna make a comment, that because I